Welcome back to Class with Cole at CWM University, and today our objective is solve for an unknown variable in a one-step equation and a one-step inequality. Your students are not bad at algebra. They've been doing algebra since kindergarten. The only thing that has changed is the box has turned into a variable. So why does everything fall apart when they get to 6th grade? For some reason, the variable confuses them. So let's look at some ways that we can help the student be able to still solve algebra without it being confusing. Let's first go over some vocabulary words that you would need to use with your students while you're teaching them how to solve one-step equations and one-step inequalities. And then we'll move on to some examples. For our vocabulary, we have zero pair, inverse operation, equivalent, variable, equation, inequality, substitution, parentheses, balanced, open, closed, and cancel out. These are some words the students will need to know when they're solving one-step equations and one-step inequalities. Okay, so I used to tell a story when teaching my students how to solve equations or inequalities. I love a good story. So I will always tell them that the variable is an invader and you don't want to be on the same side as the invader. So I used to make them draw a line down the equal sign, which represent a wall. So here on this picture, you see that there's bricks going down the equal sign. It's like a wall. So if you're on the side of the invader, you want to get on the opposite side of the wall. Now, the thing is, if you have to go on the other side of the wall, you change. So if you're a positive 6, to get to the other side of the wall, you have to turn into a negative 6. Or if you are a negative 5, to get to the other side of the wall, you have to turn into a positive 5. So if you look at this example here, that positive 6 has turned into a negative 6. And whatever you do to one side of the wall, the other side of the equation, which a lot of times you hear teachers say, what you do to one side of the equation, you have to do to the other side to keep it balanced. So if I do plus 6 minus 6, that turns into a zero pair. And then I would have to do subtract 6 on the other side as well. So if I do that positive 6 and negative 6 on the left side will cancel out. So it will turn into a zero pair, so it's no longer there. And I will have the invader by itself, and then I can find out its true identity. So if I do 12 minus 6, it will equal 6. So the invader, which is the variable's true identity is positive 6. So the whole goal is to try to find the identity of the invader. So it kind of makes this story where it's kind of fun for the students and some way they can remember. So whatever I do to one side of this wall, I need to do to the other side to get to the other side. So the students will need to know what an inverse operation is. So inverse operations just mean the opposite of, so if I'm adding, the inverse of adding would be subtracting, or the inverse of subtracting would be adding. Inverse of multiplication will be division. So the inverse of division will be what? Multiplication. Exactly. So they would need to know this to help them solve the equations and the inequalities. So for some reason, the state tests like to try to confuse the students. I don't know why. I think they think it's fun. But there will be different formats that the students may see. So we're gonna go over some of those formats they may see, and your students need to be aware of this. So for example, the addition, they may use a plus 6, and then they may show you 6 plus a. They need to know that that still means you're just adding. Means the same thing. For division, they love to show different ways to divide. They may have a/25, they may have a and then the division sign 25, and then they may have a over 25 like a fraction, but they all just mean to divide. And then for multiplication, this is when they have the most. They may have the letter by a number. So I always ask my student, what does the letter by a number mean? Means to multiply. So 25 by a, that means to multiply. They may actually have the multiplication symbol, so 25 times a. They may use a dot to represent multiplication. And then they may use a parentheses. They may have 25 parentheses and put the a in it. They all mean to multiply. So the students need to know, if they see these different type of formats, what each one of them mean. Okay, I think that I've covered all the formats and the different ways you will see the operations, but let me know in the comments if you've been teaching one-step equations or inequalities for a while and you've seen other formats that represent a certain operation. Put in the comments. All right, we have our problem with a plus 12 equals 32. Our invader is a, and we need to get 12 to the other side of the wall. So the opposite of positive 12 is negative 12. So I'm going to subtract 12 on each side. And then if I add 12 and then subtract 12, that turns into a zero pair. So now I have the invader by itself, the variable by itself, and 32 minus 12 is going to be 20. Now that I know the invader's true identity, so the variable equals 20, I need to check. So I'm going to draw that brick wall down the equal sign to keep my equation balanced. And then I'm going to substitute 20 for A. And this is the way I'm going to check my equation. So then I'm writing down 20 plus 12 equals 32. And then I need to check the left side of the equation to see if it equals the right side. So what's 20 plus 12? It is 32. Now, is 32 equal to 32? The student needs to ask themselves this to make sure they're correct. And if it is equal, then they're right. So now I need to graph my the answer to my variable. So my variable was 20. So on my number line, I'm going to put positive 20 and a negative 20. And then I'm going to put a circle above positive 20 and fill it in because that's the only answer I could have. Okay, so our next invader is B. The variable is B. So now I need to get the negative 5 to the other side of the wall. So what's the inverse of subtracting? It's adding. So I'm going to add 5 to both sides. What I do to one side of the wall, I must do to the other side. So I'm going to put plus 5 on the other side of the wall. And then I'm going to subtract. Negative 5 plus 5 gives me a 0 pair, so I can cancel those out. And I'm left with B, the variable, which equals, and on the right side, I have 15 plus 5, which is 20. So the true identity of the invader is 20. So now I need to check. I need to substitute B for 20. So I'm going to plug in 20 where I see B. Go ahead and write the rest of the equation down. And then I'm going to check to make sure I am correct. So I need to make sure that everything on the left side is the same amount on the right side. So 20 minus 5 is 15 on the left side. And then all I have is 15 on the right side. So that means that my equation is balanced. So I have checked it. I know that the invader is 20. So now I have to graph that on my number line. So I'm going to put 0 in the middle, put positive 20 on the, negative 20 on the left. And then I'm going to write positive 20 on the right. And then I'll draw my circle above 20 to show that that's the only answer I could have. Now for this one, our operation is division. So what's the inverse operation of division? It is multiplication. So I'm going to multiply by the number that's by the variable, which is 7. So what I do to one side, I have to do to the other side. So I need to multiply both numbers by both sides by 7. And if I divide by 7 and multiply by 7, I'm going to have 1. So I have 1R, which I wrote down. And then I need to do 32 times 7 to get the answer, which is 224. So now I'm going to take my answer to my variable and go substitute it for R to check to make sure I'm correct. So I'll put in 224 and then I'm going to divide that by 7. I'm just rewriting it how it was originally written. And then on the right side, I'm going to have 32. Now you can have your students do this long division on their paper to figure out what is 224 divided by 7. So ensure that it is 32. So how many times does 7 go into 22? 3 times. And 7 times 3, of course, is 21. And then they're going to subtract. 22 minus 21 is 1 and bring down to 4. And these are just the steps of long division that I'm following. And then how many 7s are in 14? There's 2. And then don't forget to finish your problem because you don't want a remainder if possible. Sometimes you may have it, but this one we don't. So I know that the left side equals 32. And I'm going to keep bringing that equal sign down the brick wall. And then the right side is 32. So my equation is balanced. Now I need to graph my variable on the number line. 224 positive and 224 negative. This should show that the numbers exist on the number line. You can have the students write all the numbers out if you want, but that's up to you. And then above 224, I'm going to put my circle and fill it in because that's the only answer I can have. Okay, so now we're going to move into inequalities. And the inequality I have is a less than sign. I'm still going to do the same thing, drawing my brick wall, do the opposite of positive 10, which is negative 10. So subtract 10 on both sides. And then a plus 10 minus 10 gives me a 0 pair, so I can cancel those out. And I'm left with A as my variable. And then I need to solve what is 32 minus 10. And 32 minus 10 is 22. And I keep my less than sign. So now I want to check. In order to check, I need a number that is less than 22 to make this true. So I'm going to use 20. You could use 2, you can use 5, you can use 4, as long as the number is less than 22. So I need to make the inequality true. So 20 plus 10, and then it's less than 32. So what is 20 plus 10? That is 30. And then 30 is less than 32. So I know that that is correct. So now the graphing of this is a little different. When it's a less than sign, the circle is open. So I'm going to put 22 and negative 22 on my number line. So I'm going to put a circle on top of 22. And then to help myself know which way the arrow goes, I know I need every A has to be less than 22. Also, if the variable is on the left side of the inequality, it always shows you which way to point the arrow. So that helps the students. Okay, so now this one is a greater than or equal to sign. And with the greater than or equal to signs, our circles will be closed. We're going to solve it the same way. Draw our brick wall down the middle. And a letter by number means to multiply, so we have to do the opposite. So we're going to divide both sides by 7. And when you multiply and divide by the same number, you get 1. So 1b is greater than or equal to 49 divided by 7, which is 7. So to check it, I need a number that is greater than or equal to 7, so it will come out correctly. So I'm going to use 8. And then I keep the sign greater than or equal to, and then keep 49. So now I'm going to solve the left side of the equation. 7 times 8 is 56. And then I'm going to keep the sign greater than or equal to 49. So then I have to ask myself, is 56 greater than or equal to 49? Yes, I'm correct. Now for our graph, we're going to put our, I wrote down the inequality to show which way my arrow should be pointing. Should be pointing to the right. And since it's or equal to, I have to fill it in. And then it's pointing to the right. Okay, this is our last example. And on this one, if you have to multiply or divide by a negative number, when you're done solving the problem, you have to flip the inequality. Anytime you multiply or divide by a negative number, you have to flip the inequality. And this is something that your students will have to know to pick the right answer. All right, so we're going to divide by -3 on both sides because the letter by number means to multiply, so we have to do the opposite. So divide by -3 on both sides. And then if you multiply and divide by the same number, cancel out to become 1. So I have 1t, and then I have to flip the sign because I divided by -3. And then I'm going to solve the right side. 21 divided by -3 is a -7. So whatever number I choose to use to check my answer, it has to be less than or equal to -7. So I can use -8, -9, -10. So I'm going to pick one of those numbers to check my answer. So I'm drawing my brick wall down the inequality, and then I'm going to substitute t for -8. And then keep my greater than or equal to sign. And then I'll keep 21 on the right side. So whatever side they're on, I'm going to keep them there. Now, what is -3 times a -8? That's going to be a positive 24. You have to know your rules with your negatives and multiplying them. So positive 24 is greater than or equal to 21. And then I have to graph my answer. Now, when I graph my answer on my number line, the inequality has to stay the same as it was when I first started the problem. So everything's going to go to the left. I hope this video has helped. Please let me know if you try this on your students. Clicks for your students, they get the analogy of the invader and getting away from the invader. And what if I do to one side of the equation, I have to do to the other side. What if I do to one side of the inequality, I have to do it to the other side. Please let me know if it works. If you have different ways that you teach one-step equations and one-step inequalities that work for your students, let us know in the comments. Also, let me know if you would like access to the copy of the notes that I used during the video. I can make a copy of the notes and give you all access. Just let me know if that would be helpful or not. Please like this video, share it with a teacher that it may help. Leave me a comment. Let me know what you thought about the video. Are there different objectives that you would like me to cover that I haven't covered so far on my page? If you haven't subscribed, please subscribe. Thank you so much for watching this video. And you already know. Until next time, peace out.